Okay, so lesson 37 is the applications of rational expressions. So what we're going to do is we're going to take the rationals that we learned in solving for rationals. We're going to apply it to a word problem. So what we have here is we have a poster that has 400 square centimeters of printed matter, right? So the whole thing area is 400. Its margins are 10 centimeters from the top and the bottom and 5 from each side. So suppose that the width of the poster is in W centimeters, determine formulas for its length and its area. And then use that formula to determine the length and area of each width. Okay, so here's the two. We're going to work with 20 and 25. So let's create an equation here. So area for the whole thing is 400. So we talk about the area of a rectangle is length times width. Well, what's the length? The length is whatever the length is minus 20. It's 10 on the top, 10 on the bottom. And the width is whatever the width is minus 5 on each side, which is minus 10. Okay, so now what we do is we have we want to get L by itself. So what we do is we divide both sides by W minus 10. So W minus 10 on both sides. So those reduce down. So you're left with L minus 20. We can just flip them around in case you want the L on the left-hand side. It's not a big deal. You can work with it the other way. How do we get rid of the negative 20? Well, we add 20 to both sides. So we have an equation now. L equals 400 over W minus 10 plus 20. Well, how do we add two things? You have to have common denominators. So the LCD is W minus 10. So this one's already fine, right? The W minus 10 is already here. So we got to multiply both the numerator and the denominator by W minus 10. So we do the work there. We're going to have to distribute that. So we end up with 400 plus 20W plus 200. And then the bottom is just W minus 10. Now, look at this thing. We can reduce this down, collect the 400 minus the 200, and we end up with 200 plus 20W over W minus 10. Okay, so that is just taking the formula and creating it so it's on. So it's all L equals. That's all the question asked. Then what we can do is we can plug in different numbers. So the first one I think was B said 20. So if you look back up here, right, we're talking about determine the length in the area. There's the width. The first width is 20. We'll do the same thing again for 25. So all we do is plug in the 20 wherever the width is, do all the math. We end up with 60 centimeters. How do you find the area? Well, that's easy. 60 times 20, right? Length times width, 1,200 centimeters squared. What if the width was 25? Plug in 25, we do the math, we end up with 46 and 2/3. Now, leave it in fractional form. Don't put it as 0.6 repeater. Fractional form is always something we can reproduce, so that's why we like it that way. Multiply by 25, we end up with 1,166 and 2/3 square centimeters. So that one is just creating a formula and then rearranging it around so it equals L and then plugging in the necessary things. Okay, flip the page, and let's do these rate problems. These are often confusing for students. I'll try to explain this as best I can. So what we have is in a triathlon, it consists of 3 parts, right? So there's swimming 5 kilometers, cycling 30 kilometers, and running 20 kilometers. Different triathlons are different, but this one is just 5, 30, and 20. So in general, a contestant runs at an average speed of X, swims at an average speed of X divided by 5, right? So if they run at 5, then they would swim at 1, right? Because 5 divided by 5. And then cycle an average speed of 5 times X. So if they were doing 5 for X, then it would be 25 that they cycle at. And X is in kilometers per hour. So determine an expression for the total time taken to complete the race. So let's look at this here. So we want to do time, then what we do is we can take the distance divided by the speed. Okay, so the distance here for swimming is 5. The speed of swimming is X divided by 5. So we have 5 divided by X minus 5. And X divided by 5. A lot of students don't like that, so let's just look over here. We can go 5 divided by X over 5, which is 5 times 5 over X, which is just 25 over X, right? So we can change this whole thing right here to 25 over X. Okay, the distance for cycling is 30 kilometers, and they cycle at a speed of 5x, so 30 divided by 5x, that reduces down to 6x. And then they run 20, and the average speed they run is x, so that's 20 over x, so it's already set up. Okay, now, what we can look at here is we have 25 plus 6 and 20. What does that equal? 51, right? So 51 over x. So all of these added together, right? Because we have common denominators, x, x, and x. We can just take the numerators and add them all up. We end up with 51 over x. So what that tells us then is, okay, if Cynthia can swim 2 kilometers per hour, how long will it take her to complete the race? Okay, remember the swimming was x over 5, and it takes her, and she swims at 2 kilometers. So that equals 2 over 1. So all we do is we cross multiply. You know how to do that. X times 1, x, 5 times 2. So 10. Okay. So 50, there's our formula. 51 divided by 10, 5.1 hours. Now, if Shaitha can cycle at 40 kilometers per hour, how much longer will it take her to complete the race? Okay, so it's a different formula this time, right? The cycling one was 5x. And so 5x equals 40, solve for x equals 8. You take the 8, you plug it back into that original formula, the 51 over x. So 51 over 8, so 6.375 hours. So it's going to take her a little bit longer. In fact, it takes her 1.275 hours longer. Now, in reality, you have to realize x is not a constant thing, right? Because people speed up and slow down when they're doing this. But when it comes to this math question, we have to assume that x, 5x, and x over 5 are constant, right? Whatever number you pick, if x was 10 or x was 5 or x was 7, it's throughout the whole thing. Okay, so that is lesson 37.